Welcome to Learning to Engineer. Why is the average power of an inductor 0? Same goes for capacitor as well. First, let us answer this question. Before we go into this video, what is an inductor? What are we trying to achieve by using an inductor in a circuit? Inductors are usually present in coils, in solenoids, it's present in motors, and this concept is used widely in a different range of electrical devices. Inductor stores energy in the form of magnetic field. The inductor is just one long wire which is wound in terms of coils, and it will have a lot of turns inside it. It will have around 1000 or 2000 turns such that the magnetic effect produces the magnetic field along the conductor. According to the clock screw rule, if this is the direction of the current, the magnetic field will be in this direction. So, an inductor stores the current in the form of magnetic field. The EMF that is induced across the ends of this inductor E is directly proportional to the rate of change of current that's flowing through it. It's not just that, let us say you have passed 5 ampere constantly, then no EMF will be induced across it. This current has to be alternating in nature, not necessarily a sine wave, but this should be alternating. It can be a square wave, it can be a sawtooth waveform, it can be a triangular pulse, it can be anything, but this current should be in varying nature. Okay, so the EMF E, let me write it bigger. Okay, so E is directly proportional to the rate of change of current. To remove this proportionality, we are introducing a constant called self-inductance or L. Self-inductance is the ability of the coil to generate the magnetic field when the current is in alternating nature. Okay, so this much is the story. Here, this small I refers to the instantaneous current that is passing through this inductor. And this refers to the instantaneous EMF. If it is a sine wave, this instantaneous current will be of the format maximum value times sine omega t. For now, let us take this omega t to be theta. Okay, this is also called as Im sine theta, where theta is equal to omega t. Okay, so what is the EMF now? The EMF is equal to L into the differential of Im sine omega t. This is equal to L omega into the maximum value of current into cos omega t. Because if you differentiate this term, you will get omega into Im cos omega t, because differential of this will give you omega into Im. Okay, so I am just clubbing this term and calling this as XL. This is called as the inductive reactance. Okay, so E is equal to XL into Im into cos omega t. How can we write cos omega t as sin 90 plus theta, right? Because this also illustrates the fact that the EMF leads the current by 90 degree in an inductor. If this is the current and this represents the EMF, the current will lead the EMF by 90 degrees. Okay, so this can be written as XL into Im sine omega t plus 90 degrees. Okay, so let us come back to the original question. What is average power? First of all, what is power? Power is voltage into current. Average power means the power that is absorbed by the inductor in one particular interval of time. Let us say you are passing this current for 15 minutes. Okay, this rate of change of current and this EMF, this happens for 15 minutes. In this 15-minute duration, what is the average power that's absorbed by this inductor? because this current is alternating in nature. In one particular time it will be sending current, in one interval of time it will be absorbing current. So there is no complete absorption of power or complete delivery of power. Since this current is alternating in nature, it will be plus sometimes, it will be minus sometimes. So it is only possible for us to find out the average power in an inductor. Whereas if you take resistor, it will be 100% absorbing in nature. So it will only absorb current. If you take a power source, it will only deliver current throughout throughout the time in which it is operated. If you take a resistor, throughout the time in which it is operated, it will be absorbing current. But whereas in an inductor, it is not the case. Since this current is alternating in nature, it will be absorbing during one particular interval, it will be delivering during another interval. Okay, so this EMF is also alternating in nature. So it is possible for us only to find out the RMS power or the average power or the form factor and so on. There is no term called as power in an inductor. It is either an average power or an RMS power. Okay. So what is the average power in an inductor? What is the general format of this? The average power is nothing but 1 divided by the time period into this integral from 0 to t, instantaneous voltage into instantaneous current with respect to time. This is average power. So taking a scenario where we are passing a sine wave into an inductor, this time period will be 2 pi and this EMF is this and this instantaneous current is this. Let's substitute them and find out the average power in an inductor. The average power is equal to 1 divided by 2 pi into the integral 0 to t, which is 2 pi. Instantaneous EMF we saw is XL into Im sine omega t plus 90 degrees. Okay, this is the instantaneous EMF. The instantaneous current is Im into sine omega t. This integral happens with respect to omega t. So for time being, what we will do, we will call this term as the maximum EMF Em and we will call omega t as theta, just for our easy calculations. Okay, otherwise we will be writing long equations again and again. So what is P? P is equal to 1 divided by 2 pi. This integral happens from the limit 0 to 2 pi into Em sine theta plus 90 degree into Im sine theta d theta. Okay. So let us take the constant terms outside this equation. We know that sine 90 plus theta is cos theta, right? So this term becomes cos theta. So clubbing together we will get Em into Im by 2 pi 0 to 2 pi cos theta into sin theta d theta. We know that sin 2 theta is 2 into cos theta into sin theta. Right? So what is cos theta into sin theta? Sin 2 theta divided by 2. So this is becoming a purely sine function. It is 0 to 2 pi into sin 2 theta divided by 2 d theta. So you all know, okay, if we integrate a sine function, we will get 0. So the average power of a pure inductor is always 0. Why do we insist on the term pure inductor? Because only in a pure inductor, the voltage will be leading the current by 90 degrees. Otherwise, it will not be 90 degrees exactly. There will be a small variation in the angle and hence this power, this average power will not be 0. So, meaning wise, what we understand from this? When the current is alternating in nature, the current will be passed from the source to the inductor during one interval, and during the other interval the current will be sent back to the source by this inductor. So that is why the average power is 0. At one point it is absorbing, in the second half cycle it is delivering. Okay, so that is why the average power in an inductor is 0. Can you all think of what is the average power in a capacitor? Type your answers in the comment section. And don't forget to subscribe to Learning to Engineer for more updates on similar concepts. You can write me an email at learningtoengineer@gmail.com for more doubts and more clarifications. Thank you.